my title there is doing a lot of the heavy lifting about what I'm going to discuss. But to start us off, I want to address that unwanted fires are bad, and firefighters put themselves at acute risk for harm and potentially death when they go into fighting fires. So the goal of this project is then assess the toxicity of lithium-ion fires to help improve safety and overhaul operations. And to help out, so overhaul operations in particular are the point at which, after a fire is initially extinguished, firefighters will go into a compartment or a dwelling and then assess for any more they'll assess for where it's smoldering and hot spots. So they're checking it for reignition. So, and that point in the overhaul is when we want to really check what's going on here. So we do that in a twofold method. With experiments and numerical simulations. So on the experiment side of things, we actually do prescribed burns. So in this case, we set up certain dwellings and rooms to try to simulate what an actual fire would look like as best as we possibly can. And the reference image I have here is of a small electric scooter. So you can see that quickly burning. So we have as good as information as we can possibly get. What we don't have is total fidelity about the actual domain information that we get, and use that as boundary and initial conditions for my numerical simulation. So downside is those are very expensive. Numerically, upshot, we have total fidelity about the domain, and we have all of our information about the scalar variables like temperature and like concentration. So in synthesizing both of those things together, what we can then do is help inform and guide some of these overhaul operations so we can yield a fast assessment method for firefighters to know the toxicity and of the dwellings they're going into. Thank you.